This is video 7C for the Year 11 Mathematical Methods course. In this video, we're going to be covering some example questions from the cosine function under the topic of trigonometric functions. The 8 questions we will be going through are now displayed on the screen, so I recommend that you attempt these questions before watching the rest of this video. Question 1. What is the amplitude of a cosine wave with equation y equals 5 over 4 cos of 3x take pi over 12 plus 1? So we have y equals 5 over 4 multiplied by cos of 3x take pi over 12 all plus 1. And we know that the amplitude of a cosine function is given by the modulus, or in other words, the size of this leading coefficient here. So the amplitude, in this case, is equal to the modulus of 5 over 4, which is just equal to 5 over 4. Question 2. What is the period of the cosine wave with equation y equals negative 2 cos of pi over 3x take 1/2 all plus 4? So we have the cosine function of y equals negative 2 multiplied by cos of pi over 3 multiplied by x take 1/2 plus 4. Now the first thing that we're going to do here is rewrite this bracket in the standard form for a cosine function. So to do that, we're going to factorize out this pi over 3. And by doing this, we get y is equal to negative 2 multiplied by cos of pi over 3 multiplied by x take 3 over 2 pi all plus 4. And now we know that the period of a cosine wave is given by 2 pi divided by the coefficient of x, which in this case is this pi over 3. So we're going to have 2 pi over 3, which is equal to 6. Question 3. Describe the transformations that map the graph of y equals cos of x to the graph of y equals cos of x plus 5 pi over 6 all plus 1/2. So the cosine function that we're working with here is y equals cos of x plus 5 pi over 6 all plus 1/2. Now, in order to describe the transformations which map the graph of y equals cos of x to the graph of this function here, we need to first of all identify our a, b, c, and d constants. In this case, a is equal to 1 since this is the coefficient of the cos function. B is also equal to 1 since this is the coefficient of the x. C is equal to negative 5 pi over 6. And then d is equal to 1/2. And so now, in order to describe the transformations which map the graph of y equals cos of x to the graph of this function here, we can say the following. Now, first things first, since the value of a and the value of b are both equal to 1, then it means that we do not have any transformations from these two constants. In other words, we do not have any vertical dilations and we do not have any horizontal dilations. So the only two transformations that we need to describe are this one here and this one here. Now, since the value of c is equal to negative 5 pi over 6, then we can say that the graph is being translated to the left by 5 pi over 6 units. And since d is equal to 1/2, then we can say that the graph is being translated up by 1/2 unit. So in total, we can say that the graph of y equals cos of x is being translated to the left by 5 pi over 6 units and up by 1/2 of a unit. Question 4. Describe the transformations that map the graph of y equals cos of x to the graph of y equals negative 1/2 cos of 4x takes 7 pi over 3 plus 6. So the function that we're working with here is y equals negative 1/2 multiplied by cos of 4x take 7 pi over 3 all plus 6. Now before we do anything here, the first thing that we need to do is rewrite this bracket in the standard form for a cosine function. In other words, we need to factorize out this 4. So we can rewrite this function as y equals negative 1/2 multiplied by cos of 4 multiplied by x takes 7 pi over 12 all plus 6. And now we can identify our a, b, c, and d values. So first things first, a is this negative 1/2, b is this 4, c is this 7 pi over 12, and then d is this 6. And so now if we want to describe the transformations that map the graph of y equals cos of x to the graph of this function here, we can say the following. So first things first, because we know that a is equal to -1/2, then we can say that the graph is being dilated vertically by a factor of -1/2, and therefore the graph has an amplitude of the size or modulus of -1/2, or in other words, +1/2. Now, furthermore, because this dilation factor is a negative number, we also know that the graph is going to be reflected about the x-axis, so we can just write this here as well. Secondly, because the value of b is equal to 4, this means that we're going to have a horizontal dilation by a factor of 1/4, and so therefore the graph now has a period of 2π/4. And 2π/4 simplifies to π/2, so in other words, the graph has a period of π/2. Moving on, because we know that c is equal to 7π/12, then we know that the graph is going to be translated to the right by 7π/12 units. And then finally, because we know that d is equal to 6, this means that the graph is going to be translated up by 6 units. And that's that. So in summary, the graph of y equals cos of x is being dilated vertically by a factor of -1/2, which therefore means that the graph will now have an amplitude of 1/2, and it's also reflected about the x-axis. It's also going to be dilated horizontally by a factor of 1/4, so the graph now has a period of π/2, and it's also translated to the right by 7π/12 units, and up by 6 units. Question 5. Sketch the graph of the cosine function y equals -2 cos of x take π/4 plus 1 on the domain of x being between 0 and 2π. So we're working with a function of y equals -2 multiplied by cos of x take π/4 all plus 1. So first things first, we're going to insert a set of axes that we can sketch the graph on. And for this particular set of axes, we're going to say that every 4 grid lines along the x-axis represents pi. So that means that this point here is pi, and this point here is 2π. And we're also going to say that every grid line along the y-axis represents 1 unit. So the first thing that we're going to do here is plot out all the important points of the basic cosine function of y equals cos of x. And those points are here, 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 and here. And now we need to apply all the given transformations in order from left to right. So, first things first, let's apply the transformation correlating to this -2 out the front. So in order to apply this transformation, we are going to multiply all the points y coordinates by -2. So this point here is going to get boosted down to -2. This point here is going to stay where it is. This point here is going to get boosted up to +2. This point here is going to stay where it is. And then this point here is going to get boosted down to -2. Now, in order to apply this π/4, we need to shift all the points to the right by π/4 units. So this one here is going to go here. This one here is going to go here. This one here is going to go here. This one here will go here. And this one here will go here. Now, even though this new point here lies outside of the domain, we'll still keep it on just so we can understand the general shape of the graph at the very end. And then finally, to apply this +1 at the back, we are going to shift all these points up by 1 unit. So, this point here goes here. This point moves up to here. This point moves up to here. This point moves up to here. And then finally, this point gets moved up to here. And so now by connecting all these transformed points with a smooth curve, we get the following. So first things first, you'll notice that we've stopped drawing the graph at x equals 2 pi, since that is the upper bound of our domain, but we also need to backtrack this graph to x is equal to 0. So if we just continue sketching the general shape of this curve, we can backtrack this graph to this. Question 6. Sketch the graph of the cosine function y equals 3 cos of 1/2 of x, take 1, on the domain of x being between 0 and 3 pi. So the function that we're working with here is y equals 3 multiplied by cos of 1/2 of x, all take 1, and we have the domain of x being between 0 and 3 pi. Now, first things first, let's insert a set of axes that we can sketch this graph on. And now for this particular set of axes, we're going to say that every 4 grid lines on the x-axis represents pi units. So that means that we've got pi here, we've got 2 pi here. Furthermore, we're going to say that every grid line on the y-axis represents 1 unit. Now, first thing that we're going to do here is plot out all the important points of the basic cosine function of y equals cos of x. So that is this point here, this point here, this point here, this point here, this one, and that one. And now we're going to apply the transformations to these points in the order from left to right. So first things first, let's consider this 3. Now in order to apply this transformation, we need to multiply every single point's y-coordinate by 3. So this point here gets boosted up to positive 3. This point here stays where it is. This point here gets boosted down to negative 3. This point here stays where it is. This point here gets boosted up to positive 3. This point here stays where it is. And then this point here gets boosted down to negative 3. Next, this 1/2. Now what we need to remember about the coefficient of x is that we have to apply a horizontal dilation of the factor 1 over b. So in this case here, that dilation factor is going to be 1 over 1/2, which is equal to 2. So what this therefore tells us is that we're going to get all the x coordinates of these points and then double them. And so this first point isn't going to move anywhere. This point here is going to get boosted up to 2 pi. And this point here is going to get boosted up to 3 pi. Now, what we'll notice about this point here, and this point here, is that if we double their x coordinates, they're actually going to go outside of a domain that we've been given. And so given that, we're not going to worry about transforming these 3 points anymore because they're going to lie outside of a domain that we want to sketch the graph for. And then finally, this -1 means that we need to translate all these points downwards by 1 unit. So this point here is going to get shifted down to this point here. This point here is going to get shifted to here. This point here is going to get shifted to here. This point here goes to here. This point here goes to here. This point here goes to here. And then this point here goes to here. And so now that we've applied all the transformations that we have, let's connect all these points with a nice smooth curve. Question 7. Find the equation of a cosine function with the following graph. Alrighty, so with a question like this, our ultimate goal is to write this cosine function in the form of y equals a cos of b multiplied by x takes c, all plus d. So we now need to find the values of a, b, c, and d. And so let's bring back the graph that we were given in the original question, just so we can analyze it a bit further. Alrighty, so first things first, we know that the value of a is given by the maximum value take the minimum value all divided by 2. For this particular graph, we can see that the maximum value is 0 and that the minimum value is at -2. And so therefore, a is going to be given by 0 take -2 all divided by 2, which is equal to 1. Also, we know that d is given by the maximum value plus the minimum value all divided by 2, which in this case is going to be 0 plus -2 all divided by 2, which is equal to -1. And we also know that the value of b is given by 2 pi divided by the period, so now let's focus on finding the period for this graph. And in order to do that, let's consider the positions of the adjacent peaks. So in other words, this point here and this point here. The first peak has an x-coordinate of 0, whereas the second one has an x-coordinate of pi. And so these 2 points here are separated by a distance of pi, which therefore tells us that the period of this graph is pi. So therefore, b is going to be equal to 2 pi divided by pi, which is equal to 2. And now finally, the value of c. And in order to work on finding the value of c, we are going to use the fact that the first peak of this graph occurs at x equals 0. Because we know that for the basic graph of y equals cos of x, then the first maximum occurs when x is equal to 0. However, we also need to consider what happens to this first maximum after it undergoes this horizontal dilation. So because the value of b is equal to 2, then after the horizontal dilation, the first maximum point should occur at x equals 0, so this point here, divided by the value of b, which is 2, which is still just 0. And so because on our graph the first maximum occurs when x equals 0, this therefore means that there has been no horizontal shift. Or in other words, no horizontal translation. And so therefore, we know that c is equal to 0. So we found that a is equal to 1, b is equal to 2, c is equal to 0, and d is equal to negative 1. So let's substitute all these values into the general cosine function. Now, in order to double check this answer, let's use our graphics calculator to plot out the graph of our cosine function and make sure that it matches the original graph that we're given. Now let's also change up the viewing window to match that of the original graph. So x we can say is between negative pi over 2 and 2 pi. And the minimum y value we're going to set at negative 2.5, and then the maximum y value as 0.5. And so what we want to do from here is make sure that the positions of the maximum points and the minimum points match up with that of the original graph. So on the original graph, we can see that we've got a maximum point at x equals 0, so let's just track this one here. And as we can see here, we have a maximum point with a y coordinate of 0, which is exactly what we want. And we also want to test this for when x is equal to pi. And in which case, we get another maximum point, so that's really good there. Let's now test out the two minimum points. So the first one occurs when x is equal to pi over 2, so let's double check this one here. And so we can see that we've got a minimum point with a y coordinate of negative 2, so that's really good. And then we can see that the second one occurs when x is equal to 3 pi over 2, which once again gives us another minimum point with a y coordinate of negative 2. So just by double checking these maximum and minimum points, we can be pretty confident that the equation that we have is indeed the correct answer. Question 8. Find the equation of a cosine function with the following graph. Alrighty, so with a question like this, our ultimate goal is to write our cosine function in the following form, of y equals a cos of b multiplied by x takes c plus d. And so what we need to do from here is find the values of a, b, c, and d. Now in order to do this, let's quickly bring back the graph that we were given in the question, just so that we can analyze it in a bit more detail. Alrighty, so first things first, we know that the value of a is given by the maximum value take the minimum value all divided by 2. The maximum points on this function are these 2 points here, which correlate to a value of 3.5. And then the minimum points are these two here, which correlate to a value of negative 4.5. And so therefore, a will be equal to 3.5 take negative 4.5 all divided by 2, which is equal to 4. We also know that d is equal to the maximum value plus the minimum value all divided by 2, which is equal to 3.5 plus negative 4.5 all divided by 2, which is equal to negative 1/2. Now, we know that the value of b is given by 2 pi divided by the period, so now let's focus on finding the period for this graph. And in order to do this, let's use the two adjacent minimum points, which are here and here. This first minimum point has an x-coordinate of negative pi over 4, and the second one has an x-coordinate of 3 pi over 4. And so therefore, these 2 points are separated by a distance of pi, and so therefore, this graph has a period of pi, which means that b is equal to 2 pi divided by pi, which is equal to 2. And now finally, the value of c. In order to find the value of c, we're going to consider the position of this first maximum point here, which has an x value of pi over 4. Because we know that for the basic cosine function of y equals cos of x, then the first maximum point occurs when x is equal to 0. However, we also need to consider the fact that we have a horizontal dilation happening with this graph. And so therefore we can say that after the horizontal dilation, the first maximum point should occur at x equals 0 divided by b, which is 2, which is equal to 0. So in other words, after this horizontal dilation, we should still have the first maximum point occurring when x is equal to 0. However, as we established previously, our first maximum point occurs when x is equal to pi over 4. What this therefore means is that we have a horizontal translation to the right by pi over 4 units. Which therefore tells us that c is equal to pi over 4. So, we found that a is equal to 4, b is equal to 2, c is equal to pi over 4, and d is equal to negative 1/2. So let's substitute all these values into the general cosine function. And now, in order to double check this answer, let's use our graphics calculator to plot out the graph of this cosine function here, and confirm that it matches the one originally given. And we're also going to set the viewing window to be the same. So we're going to set the x domain between negative 3 pi over 2 up to positive 3 pi over 2. The minimum y value can be negative 5, and the maximum y value can be positive 4. And so what we're going to do from here is confirm that all the maximum and minimum points on the original graph are matched by the one that we just produced on the calculator. So on the graph, we can see that we have a maximum point at negative 3 pi over 4 and positive pi over 4. So let's confirm that we've got those over here as well. So at negative 3 pi over 4, we have this maximum value at positive 3.5, which is great. That's exactly what we want. And if we check out when x is equal to pi over 4, we have the exact same thing, which is really good. And we can also see that on the original graph, we have minimum points when x is equal to negative pi over 4 and positive 3 pi over 4. So let's make sure that these here are matched as well. So if we consider the graph when x is equal to negative pi over 4, we can see that we've got this minimum point here at y equals negative 4.5, which is great. And then if we consider when x is equal to positive 3 pi over 4, then we have another minimum point with a y coordinate of negative 4.5, which again is really good because that matches up with our original graph. And overall, this is really good for us since the maximum points and the minimum points of our function match up with those presented on the original graph. So therefore, we can be pretty confident that what we've got is indeed correct.